Welcome to the intersection of technology, cybersecurity, and society. Welcome to ITSPmagazine Podcast Radio. You're about to listen to a new Redefining Technology podcast. Standing on 2 feet, having dexterous hands, developing a language that allows us to communicate, and the ability to understand abstract concepts. These are all part of the equation of humanity. Still, it is the capacity to create tools and advance the technology that has allowed us to thrive on this planet, and maybe on others. Knowledge is power, now more than ever. Blue Lava is the first business platform for CISOs to manage their security program. Blue Lava guides security leaders to effectively measure, optimize, and communicate their security program with confidence and ease in one platform. Learn more at bluelava.net.
Devo unlocks the full value of machine data for the world's most instrumented enterprises. The Devo Data Analytics Platform addresses the explosion in volume of machine data and the crushing demands of algorithms and automation. Learn more at devo.com.
Marco.
Sean.
I'm tired.
Yeah, called the artificial intelligence.
I'm tired of doing the same thing over and over and over. And,
again, me too. Called artificial intelligence.
Yeah, maybe for the mundane things, but I don't know about the creative stuff. Can it really tap into my mind and create that weird crap that comes out of my head?
We have talked about that quite a bit. You know, can it be? Well, no, that I try to avoid it, but more about artificial intelligence. Can it create art, as it is doing right now? But is it really art? And can it take over creative tasks like writing music, writing poetry, and and react maybe to those things that as human we think it doesn't take much, but there is a lot going on in our brain, even making a split-second decision. So I think we're hitting a wall there with artificial intelligence, where it seems like it can repeat tasks, make it faster, maybe, but I don't know. Maybe somebody else has a different perspective. I don't see it yet.
So. I think so. There's a conversation we had. We haven't published it yet, but with Carrie and Raphael, where we talked about AI and gaming, and they really opened my mind to my perspective on where AI fits in. And I think if you approach it from it's about to replace everything, then maybe we're not quite there. But as a way to augment humans and maybe help us along the path, or help whatever we're doing follow the path that we want it to. I think there may be some interesting things there. Today we're looking at a different something written by artificial intelligence, and that is code. So that the actual code that writes all the other stuff for us and creates the apps, creates the experience that we want. And of course, Marco, I have no idea what I'm talking about. That's why we have a guest.
As soon as you say code, I'm checking out. So.
That's right. But if you check out the code, Marco, you have to check it back in. Remember to do that. But all right, joking aside, I'm thrilled to have a longtime friend. It's been ages since we connected. We spent a lot of time together at a big yellow company, slinging code and bringing stuff to market. And good friend Mathew Lodge is on the show. Mathew, thanks for joining us today.
Thank you for inviting me. It's great to be here.
And yeah, I mean, you've been up to a lot of cool things, and I've watched you progress and grow over time, and you're working on some really interesting things now. But maybe just to kick it into gear, so folk, I know who you are. Marco doesn't, and many others may not. So who is Mathew Lodge? What have you been up to, and what's your current role?
Well, currently I'm CEO of a company called DiffBlue in Oxford, England, so out of the UK. It's a spin out from the University of Oxford, from the computer science department. And essentially, we make software that writes software. So that's kind of fun, and I'm sure we'll get into that. I mean, my background is mostly in product, and you and I worked together in Silicon Valley for a long time, and that's where I spent most of my career. I've done some really interesting, fun things. When I started out as a junior engineer, I wrote some code that flew on the International Space Station and the Boeing 777. I helped connect 6 countries to the internet for the first time in the early days of the internet, before working for a big networking vendor in San Jose that I'm sure everyone's very familiar with. So I've done some really fun things, built cloud services, and DiffBlue is solving this huge challenge where there's way more code to be written than there are people to write it.
And that's a good topic to talk in redefining technology. It's kind of like, I don't know, I'm going to start with what nightmares may be made of when you think in artificial intelligence start rewriting our own code or its own code, and where we go from there. Now, I know we're not eventually talking about that, like, conscious artificial intelligence, right. or you can if you want to, but feel free to do that. But like a software that writes software. Tell me a little bit more about that.
Yes. So, I mean, the irony of software, you think about, software has revolutionized so many industries, right? We're 11 years past Mark Andreessen's column in the Wall Street Journal. His op-ed in the Wall Street Journal about, software is eating the world and it's transforming all these different industries. But the irony is that software has never transformed itself, right? 100% of the code pretty much today is written manually. You think about any other industry where you're like, yeah, we're just going to sit down and we're going to do everything by hand, right? It sounds crazy, but that's what we do in software. And the irony is that maybe 50%, maybe more of coding is boring, repetitive, error-prone stuff. And so we thought that was a good place to start when it came to automating writing software. We can do those parts, and then basically frees up the developers to focus on the fun, creative things.
Now, maybe take us on a little journey, Matthew, because I know I've heard things like no code, and certainly there are modules, a lot of modules engineers can pull together that perhaps they don't have to do hardly any coding, but they can just pull all the services together and bundle them in a certain way and organize them in some workflow and then slap a nice interface on it, or not, just enable it through APIs, right? Which then lets somebody else use it as a module. So I'm wondering how have we come to this point where, or what point are we actually, I think is really the question. How much code is being generated, or how much code has been already created and is just being consumed? And that's kind of the question I have at the moment.
Yeah, you could sort of break it down into 3 main areas. So there's the 3 things going on to sort of tackle this problem of not enough coders out there. And so things like low code and no code. No code is essentially allowing people who are not software developers to automate processes, because a lot of software does automation, right? That's the main benefit. And so you can empower analysts and people, the kind of people who could put together a spreadsheet can now put together applications. They can, essentially automatically generate code in the background so they can become like mobile apps or web apps. And that solves one class of problem, especially around things like process automation. You're sort of putting that into the hands of people who live and breathe those processes every day and can essentially automate those without any help from software developers. The low-code stuff is really interesting in the sense that this sort of, the open source world has really pioneered low-code. And if you think about the way Python data science is done today, Python and R are the top languages in data science. And if you are a data scientist in the area, you write code, but you're not like a professional developer. You're not really interested in writing the same level of code as a professional developer. You're interested in solving a particular problem. And there are these big stacks of open source libraries that make that process a whole lot easier. So the amount of code that you write is quite small. And so in the Python world, things like pandas, and the machine learning libraries from the likes of Facebook and Google and things like Google TensorFlow. You can train a neural network across multiple machines with just a few lines of Python. But you still got organizations that run on proprietary software, and they're proprietary because that's where the differentiation is in their business. And these systems need to be built and maintained by software developers. And that is the area that's really had very little progress in there. There's been attempts to generate code in the past, but they were pretty crude. They're pretty mechanical. They wrote code that no developer would like to maintain, and that's a big issue. If developers can't maintain the code, then it's not really very useful. But what we've seen is the same kind of machine learning and AI techniques that have been used to such great effect in things like text generation, machine learning for image recognition, applying those same things to writing code.
And kind of to my earlier point of conversation we had before, where our guests basically opened my mind to think about AI differently, is if you approach it from it's going to solve everything in the big picture, maybe we're not quite there yet. So with that in mind, what's possible? Are there certain types of parts of the program that are open to AI writing code? Is it the connection between parts? Is it the logic across the part? Where does this fit in?
Yeah, it's a great question. So today, I think we're just starting to scratch the surface, and there are really two things you can use today. If you're a software developer and you want to use these techniques today and use this kind of tooling and software, there are really two things you can do. The first one is the auto-completion tools. So a company called Tab9 and a couple of others a few years ago developed very smart auto-completion, because auto-completion is not new. You've had this in development environments for a while, right? So the software knows, the IDE knows about the syntax of the program. It knows what the identifiers are, and so it can sort of help you write boilerplate code. But the auto-completion tool sort of took that one step further and okay, this looks like you're headed down a picket, like you're going to train, let's say you're going to implement a neuron. You're going to write your own machine learning code. You're going to implement a neuron. So if you think about that, the Tab9 and others basically started to give you more of the code, more of the logic, right? So think of them as companions. And then more recently, we've had GitHub with Copilot, which, as the name suggests, is something that codes alongside of you. And then Amazon Web Services a couple of weeks ago introduced Code Whisperer, very similar idea. And essentially what they did, they're trained on open public software that's available on GitHub or other repositories. And so they've seen lots of software before. And so when you start typing, they look at what you've got and they try and complete that. And so they will suggest a series of completions so you can speed up your coding. So it's particularly useful in the case of things like Copilot and Code Whisperer. It's particularly useful for what they call calling foreign lands. So you're writing some code and you're calling, let's say, Twilio, and you want to send an SMS text. And you can't remember how to use the Twilio API. You've read the documentation, but you're not really sure. You haven't done it before. Now, if you are a software developer today, then what you're going to do is go on Stack Overflow. You're going to look for some examples of code, see who's done that before, probably cut and paste some of those, tinker with them until they do what you want, and there's your code. In the case of these auto-completion tools, they've seen lots and lots of examples of calling Twilio to send an SMS. And so you put in a comment that says, I'm going to send an SMS with Twilio, and then you start typing, and it will complete an API call to Twilio, and it'll fill in everything you've currently got, knows the context, put it into an API call, and that code will be pretty close to correct. Now, it's usually not exactly correct, but it's pretty good. So there's the auto-completion. And then the second category, and the one that we focus on, is testing, where we can automatically write unit tests to test software. And that's the kind of thing that DiffBlue does, and that's what our customers use it for.
So this channel, Mathew, it's all was born from the idea that, sometimes we just do things with technology just because we can. Mm-hmm. And then we're like, yeah, we'll figure out, right? And the idea is let's do it with the good intention. And the good intention, the more we talk about this stuff and I look at technology, and the more for me, and I'm going to connect again with that famous conversation that Sean already brought up a few times, is a tool. Like it's another technological tool, just way more advanced than a hammer, right? Or the Industrial Revolution, which was advanced at the time, machinery, steam, all of that stuff.
Yeah.
But it seems to me that it's still just, and by just, I don't want to diminish it, but it's simply a tool. So you tell it what to do, and it does it.
Yes.
And when we attach to that the word artificial, and in particular intelligence, it seems to me that we bring it to a completely different ballgame, where it just decide what we need, decide what we do. It's not just, it's kind of like, all right, car, you need to self-drive yourself from point A to point Z. I don't care how you get there. So I know it's a little bit more philosophical, but can you tell me some case study where the limitation applies and there maybe you get surprised by actually what this artificial intelligence in coding can do?
Yeah. So I really don't like the term artificial intelligence, and for two reasons. Because first of all, it's not artificial. So the benefits, this stuff really works, right? And the benefits are real. And it's not intelligent. There is no intelligence involved. It's statistical methods. I mean, essentially, that's what you're doing when you're running these models to make, you're making predictions about the future. And when we write tests, so we're writing unit tests, we're writing tests that find regressions in code. And so what we do is we predict what a good test is going to be, and then we refine that test through a process of iteration. Use reinforcement learning. So that iteration is driven through reinforcement learning. We learn what a good test looks like, essentially, is what's going on. There's absolutely no intelligence in that. And similarly, with Copilot and Code Whisperer, you've got auto-completion tools. They're making predictions about what they think you're going to type next, right? Based on what they've seen before. But they don't understand your program. They don't know what you're trying to do. It's just a statistical model.
So I'm sorry to keep going back to this other conversation, but the way it was described to me is picture a paintbrush, right? And typically a paintbrush has one color. Maybe you get a little creative, you mix a few colors, and the way you apply the brush, you might get some different things. But these guys described it as this paintbrush can paint a landscape. Like with one swipe, you get the trees and the hills and the lake, and you tell the brush, this is what I want you to paint for me. And I'm wondering how that might apply to either creating code or creating test cases, where it's multiple things in one part that maybe you're covering. I don't know. What are your thoughts?
Yeah, so the kind of thing, the analogy there is the kind of stuff you can see with models that have been trained, generative models that have been trained to literally paint a landscape or come up with something like a photograph. And so DALL-E is a good example of that from OpenAI. That is most similar to the auto-completion tool because they've seen landscapes before. And they have an association between, when you say you literally type in a landscape and what a landscape looks like. And so it's essentially what it's doing is processing your text. It has a model that knows about significance of different words, if a word is a verb or an adjective and so on. And it can essentially translate that or transform that into a combination of images. And that is what's going on with the Copilot and Code Whisperer. It's a transformation. So you put something in, you've seen lots of the examples before, and so you think, the model is basically saying, I think the thing comes next is this. With unit testing, what we do there is actually much more like your gameplay example, right? So reinforcement learning is used to play a lot of games. So if you look at Google AlphaGo, is a reinforcement learning model. So in the game of Go, you've got more possible game states than there are atoms in the universe, right? Huge set of possible moves that you could play. And so techniques like, sort of brute force search, which, early game playing algorithms basically did a version of that. So Deep Blue from IBM just basically looked at every possible move in the end game and picked the best one, right? And you can do that with chess because the number of moves is much smaller. You just have to be fast. But in the case of Go, when you can't do that, then essentially what you do instead is you conduct a search, and you spend time searching in places where solutions are more likely. And so the reinforcement learning approach guides that search. And so you start, you predict what, in the case of AlphaGo, it just guesses what the potential moves could be randomly. And then it sort of plays the game out, and it builds a game tree, and it follows a tree. And if things look like they're pretty good, things are going well with this particular set of moves, then it keeps heading down that path. If things aren't going so well, it may backtrack and try something else. But essentially, you're conducting this search in this area of what look like to be good moves to find the next move. And it's not guaranteed to be the best one because you can't look at all the possible next moves. But it's much more likely to be a good move. We do the same thing when we're writing tests. We guess what a good test is going to be, and we run it against the code. So we run the test to see how well it performs, how much coverage does it get, how good is it as a test. And then we predict what a better test would look like. We could try that. And then if things are getting better, then we keep going and we predict more tests, and we keep going, and we run all these tests, and we pick the best ones that achieve the objective in the case of testing, which is coverage, code coverage. So those are really the two different techniques.
That's really cool, and it helps to understand the context, in my opinion. Let's move from the fun and game to the business world, right? I mean, the inspiration for this was this article about reducing the developer shortage, and some people may already jump the gun, is like, there is not going to be more developer, we're losing the job. The robots are coming, because there's always this. But then we're like, no, calm down, we're okay, they're just helping in a way. So how is this going to address this developer shortage that we all know it's a real problem?
Yeah, it is a real problem. And I mean, none of our customers have fired anyone because of our software. That's not how they think about it, right?
Not yet.
No, well, they're like, look, we've got a lot to get done here, right? And so essentially, this is great because we're taking away a big burden for them. And we never suggest that you could replace anybody with some software, because there are things that developers can do that, current state of the art, we won't get you 100% coverage. We might get you to 70 or 80%, but we're never going to get you all the way to the top. And in some cases, the developers understand what the program is supposed to do. And this is really crucial. Our software does not understand what the program is supposed to do. We don't know what that is. We just know what it does, what it actually does. And so we write tests for that. And so developers can come up with tests that we would never come up with, our software would never come up with. But you think about the burden of that and how much time it takes and how tedious it is. And also humans are not well adapted for certain tasks. If something is repetitive and boring, then it becomes error prone, because as humans, we just don't want to think about that. And then in our world, negative test cases. Everybody can write tests for the happy path. Thinking up the path, what are all the negative test cases? Much harder, just because of the way our brains work, right? So we've never, people and development teams are like, great, I've got something that can really help me. It can take a lot of workload off me, and that gives me more time to focus on all the things that my team and my organization wants me to do. They want to have new features in the software. They want us to be more competitive. They want to. And all of that is where I can spend more time on that and less time on the mechanical stuff.
So talk to me about the process for this. So engineers, I mean, I come from a QA engineering. And so when you say the word test, my ears perk up. But clearly there was always an interaction and collaboration between the developers and the quality assurance team, even if there were QA engineers involved, that said, here's the outcome, kind of to your point, here's the outcome we're shooting for. What are the paths that could derail us from reaching that point? And
that's right.
How can we arrive there quickly with every iteration of the code that's being developed, which of course now is not 9 months time like the early days when I started developing apps. It's now in minutes, maybe even seconds for some behemoths like Netflix and others that release every few minutes or so. So how do we get there?
So Netflix, I think, deploys more than 1,000 times a day, right? So it's less than a minute. So you've got to that level of change in a software code base. How did we get to that? Because as you said, we didn't used to do that. We used to, QA at the end of the process, and we'd ship once or twice a year. And QA team would go through, some small number of times a year, because we had to go through a QA process. It might take weeks, or in some cases months, depending on what the software was and how complicated it was and so on. And what's happened in software, as you know, is the adoption of Agile. Agile is essentially taking the ideas of things like lean manufacturing production lines and applying that to software and saying, well, if you think of software as a production line, like pipeline, right, where code comes in at one end and it gets automatically deployed at the other, right? So some software is deployed onto some infrastructure. Then the idea is that you want to find problems sooner, right? The sooner you find something, the faster you can fix it. And then if you're making cars, if there's a broken component on the car, you can fix that on a production line in a couple of minutes. It's very cheap. It's just basically the cost of a new component. And so the same applies to software, and that's where unit testing comes from. So unit testing is different to sort of traditional QA. Unit tests are designed to run quickly, and they're designed to run at the same time the developer is writing that particular section of code, so that you can find those bugs right at the time the developer's in the zone, they're working on a particular thing, they understand this particular section of code. And so if they find a bug at that point, it's very quick for them to go fix that. It's not to say you don't still need QA and make sure the software does the right thing. The idea is you're trying to find more things sooner rather than finding them at the end in traditional QA. Because when you find them in QA, as you know, all you know is the software didn't do what it was supposed to do. You don't know why, so you have to triage that. The developer has probably moved on to something else. They're on their next task, whatever that is. So when the bug comes along and we can't figure out what it is, the developer has to drop what they're doing and sort of go back and sort of get into their brain, back where they were in their particular code. They have to root cause the thing. What caused this problem? What's the problem I need to go fix? I need code to fix. And then you got to run through and test it all again. So that's the difference, right? So unit testing, Agile requires unit testing. If you don't have unit tests, very, very difficult to adopt Agile, because you don't find problems until the end, and then you're back in the cycle of sort of waterfall where you're shipping a few times a year instead of multiple times a day.
Now, is there a place for this, and this being AI written code, for things like, I'm thinking availability and integrity of the application and its data, and I'm going with my QA mindset here, where once the build was done, the application had to run for 6 months, right? Just to ensure that it stayed online. Obviously, if you're releasing every few days, maybe that 6 month mark is no longer required, but there's still a level of 5 nines availability that people expect with the service. And then the other part is kind of the integrity, and this starts to cross over in cybersecurity, that we're not going to go too deep here, but just the idea that the inputs could be inserted in a certain way that throws the app off kilter, or the outputs could present information that's not relevant or inaccurate. So how does AI written code play in availability and integrity? Does it help in any way?
Yeah. So it helps on the integrity. So when we're writing tests, typically we are covering corner cases as well, and we're covering negative tests. So when what does the software do when you put in 0 or 1 versus, that something is properly formed, and understanding that behavior. And this is one of the interesting things, our software works by understanding the behavior of the program and writing tests that reflect the current behavior. So essentially what happens. And so people say, well, what happens if the behavior is wrong? What happens if there's a bug in there that nobody's found yet? And the answer to that is like, well, you deployed this application already. So the rest of the software already depends on that bug, right? And that current behavior. And so if you change the behavior, in the case of, fixing this bug, you need to know that. You need to know that you've changed behavior, because the rest of the system depends on the actual behavior, not what you thought it should do. And so this testing this way can really help you with those kinds of integrity issues, because it essentially is flagging up changes in behavior, and that can affect your integrity of your application. The other thing, if you cross over into security, is so what is a security vulnerability? It's a bug. It's where the software is doing something, but it has an undesirable side effect. Right? The side effect is the vulnerability itself. Right? So maybe there's a way to get some input into this that was not expected. Right? So you haven't sanitized the input. That's like a classic security vulnerability. It's buggy code. And essentially what you're looking to do is find those bugs and fix them. One of the things we found with poorly tested code base, and you run our product against it, it's actually a way of documenting what the code does. And so what we find is developers will look at the test that we write and they go, oh, I didn't realize it did that. Because it's poorly documented, the person that wrote it left the organization years ago. No one really understands this code base particularly well. That's a very common situation. And so and if you don't have a good set of tests that currently reflect what the application does, seeing a new set of tests that reflect the current behavior helps you understand those things. On the availability front, the other reason why people are much more interested in unit tests is because they're breaking the application down into smaller chunks to make it more highly available. So adoption of microservices, they call it. So breaking down into smaller independent chunks of an application like Netflix, so that you can improve the availability of the application by having multiple copies of those services running. And if you're going to do that, then the same problem applies, right? You're breaking down the software, you're making changes to it, and you don't want to break it, you don't want to change the behavior. And so that's the advantage of the kind of stuff we do.
So as we start wrapping here, let's bring it back to the regular user, the consumer world, mm-hmm. and what does it mean for them? I'm assuming, of course, services and product with less bugs. I'm assuming. Yep. Would they actually notice, and how much better can it get from here? And also, and this is my creative mind question, is, do you see this process improving creativity because it free the engineers and and people that innovate mind, instead of taking care of, it's like the metaphor of, if you're like taking the water out of the boat, you don't know where you're going, you're not even enjoying your trip, right? Hammering things. So the benefit to the users, the consumers, and the benefit for innovation.
It's so I think you hit on two things there, right? So the old joke about when you're up to your neck in alligators, it's hard to remember the goal was to drain the swamp, right? So that's a big part of it. So I don't know that necessarily end users would notice that there are fewer bugs, because you don't notice the thing that's not there, right? But that is definitely an advantage of this kind of approach, in that your software becomes more reliable and it has fewer defects in it. We have customers where that is a big goal for them. They just want to have fewer blow-ups in the field. That is a clear objective for them. Everyone's happier that way. The second point is about the creativity, is like you're taking a lot of the drudgery away. And we've tried very, very hard to focus on tasks that are drudgery. Get those to be, those are the things that can be automated easily, and everyone is happy. Developers are happy because they get to spend more time focusing on the more creative aspects of their job, which is mostly about figuring out, as a user, what I'm seeing is speed. I'm seeing I get more things faster in my application, right? And so the pace of innovation picks up because I'm able to ship more frequently, and therefore I can get things into people's hands. I get feedback from the users of the application much more quickly now because I'm shipping more frequently. That's the advantage. And I'm spending less time on the drudgery.
Nice. And I have one more question about the future, because I know there's a lot of A/B testing type of capabilities out there. And I'm just wondering, do you see this playing a role there for the future?
So you've already seen that there are AI-driven testing approaches for that QA phase where you can simulate humans, right? So essentially simulating human interaction with the application, and you can sort of put those two things together. A/B testing is mostly about which of these performs better, but you can also figure out, are there problems associated with this approach? Not does it work better, but is it working at all? Is it giving me what is expected? But the A/B testing thing, I think, is here to stay, particularly for end user behavior. You've got real humans using the product. You want to know what's preferable, and if it's a shopping cart, what converts better. Netflix, they're caring about recommendations for a long time, spent a lot of time focused on that. Those kinds of things really matter to end users. And I think, that A/B testing really sort of helps with the human, capturing the human behavior.
Well, Marco, I think we're continuing to reinforce that AI is a tool that helps humans, not a tool to replace humans. And it's still driven by the humans. And in this case, we're looking at the engineers, be they the app developers or the test engineers. And sounds like positive impact, even if they can't experience it, positive impact for the end users, right? More available, higher integrity, fewer bugs, perhaps even faster release cycles. So those new features come out even quicker.
I mean, once you start perceiving that these things are not substituting anything, are just making our time more valuable, maybe to work on better things, can actually be only a positive outcome for society. Now I'm being very idealistic and optimistic and utopic, but that's the point. And it's augmenting, and maybe, as Mathew said, maybe we just choose the wrong name for this thing. It's not artificial and it's not intelligence. Let's talk about that more. But no, this made me really think a lot, this conversation. So thank you so much, Mathew. I appreciate it.
Thank you. Thanks for having me on.
Thanks, Mathew. And for those listening, we'll link to the article that Mathew wrote on the newsstack.io, and we'll also provide any other resources that Mathew thinks would help learn about this topic more from a business perspective, engineer perspective, perhaps even a consumer perspective if appropriate. So thanks everybody for listening to this Redefining Technology here on ITSP Magazine.
Devo unlocks the full value of machine data for the world's most instrumented enterprises. The Devo Data Analytics Platform addresses the explosion in volume of machine data and the crushing demands of algorithms and automation. Learn more at devo.com.
Blue Lava is the first business platform for CISOs to manage their security program. Blue Lava guides security leaders to effectively measure, optimize, and communicate their security program with confidence and ease in one platform. Learn more at bluelava.net. We hope you enjoyed this episode of Redefining Technology podcast. If you learned something new and this podcast made you think, then share ITSPmagazine.com with your friends, family, and colleagues. If you represent a company and wish to associate your brand with our conversations, sponsor one or more of our podcast channels. We hope you will come back for more stories and follow us on our journey. You can always find us at the intersection of technology, cybersecurity, and society.